Hello everyone, and today we're going to be talking about logarithmic differentiation. Now, logarithmic differentiation is used when taking the derivative of the given function is either too tedious or too difficult to do without it. Now, on the left-hand side here, I've kind of gone over the steps that are going to be used while doing logarithmic differentiation. These steps are pretty much your blueprint on how to solve using this rule, and you can never go wrong using them. Now, the first step is kind of unnecessary if it's already done for you, but it just kind of looks better if you do it. And you have to place all the x's on the right-hand side of the function and all your y's on the left-hand side of the function. The second step will be taking the natural log of both sides of the function, and that will lead you into the third step, which will be applying the log rules that we learned earlier on in calculus. And below, I've kind of attached a couple of the big log rules that you'll be using. I would say these three are kind of the three big ones that you'll be using in Calc 1. And that will be when you have a product such as this, such as A times B, we can break it up as A plus B. And similarly with division, we can turn it into a difference of A minus B. And the final big one is if we have an exponent, we can drop it down in front of the natural log. Following using our log rules, we will simply take the derivative of both sides. And earlier on in calculus, we discussed taking the natural log of the derivative of a natural log. So we should be pretty comfortable doing that similarly with chain rule. And then finally, we're going to multiply y by the right-hand side of the function, onto the right-hand side of the function. Now here on the right, I've performed a pretty simple example. If we look at it here, we have y is equal to x to the x power. Now, normally taking a derivative of x to the x would be extremely difficult to do, so we're going to use log differentiation to simplify it for us. And as I said before, we already have all the y's on the left and all the x's on the right, so we don't really have to worry too much about the first step. Now, on to the second step, we're going to take the natural log of the left-hand side and the right-hand side. And like I said, with the third step, we're going to apply any log rules that are applicable to the situation. And in this situation, we have a power, so we can drop it down in front of our natural log. Now, this is a pretty simple product rule, correct? So we're going to take the derivative of both sides, in which the derivative of natural log is 1 over y. And since this is a function where we're taking the derivative with respect to x, this is implicit differentiation. So we need to call this y prime. And then taking the product rule here, we have 1 times the natural log plus x times 1 over x, which will be simplified to 1. And now, like I said before, we're going to multiply this y in the denominator here over to the right-hand side. So we're going to have y times the natural log of x plus 1. And as we look up here, we know y is equal to x to the x power. So we can say y prime, which is the derivative of this function, is x to the x times natural log of x plus 1. Now, like I said right at the beginning of this video, if we use all these 5 steps on the left-hand side, you really can't go wrong using logarithmic differentiation, and it will seriously benefit you in the long run.